Okay, let's do a quick revision for science physics for the chapter of kinematics. Okay, so I hope you have your notes with you. Okay, as I go through this, have a look at your notes again, and I will remind you what is what and what's important again. Okay, so we start off with, as usual, with definitions. All right, there are lots of definitions to remember here. Okay, what are scalar quantities, what are vector quantities, okay, keywords, scalar, right, magnitude, vectors, with magnitude and direction. So you make sure that you know the definition of scalar and vector quantities. Okay, then after that, the examples of scalar and vectors, okay, which is which, right? So remember things like acceleration will be vectors, okay, then speed and velocity, right? Which is a vector, which is a scalar, right? Take note of this. Okay, you go through yourself. Then a definition. Speed is the distance moved per unit time. Okay, don't say distance over time. Okay, so the word is per unit time, not over time, right? So keyword per unit time. So what is velocity? Velocity is the rate of change of displacement. Okay, so take note of all these definition you have, and yet another definition, just 5 in the front page alone, is acceleration. Is the rate of change of speed. Okay, or you want to say rate of change of velocity also can. All right, you write down yourself, and the most important formula follows up here. A equals to v minus u over t. Okay, I hope you still can remember. Okay, that v, what is v? Final speed, or it can also be final velocity, right? And u will be your initial speed or initial velocity, okay? Either one. And t will be the time taken. So remind you, do not mix these two up, okay? And say this initial, this final. It's always final minus initial over time taken, and that gives you acceleration. Okay, and when acceleration, okay, it can come out to be positive or negative. And when it's positive, that means it's accelerating, the speed is gaining. And when it's negative, it doesn't mean that your object is going in opposite direction. Let's say it's minus 5 meters per second squared. It means it's decelerating. I think that you know, right? Okay, and then also just remind you, when acceleration is 0, you get answer here 0, the body is at rest. Or it could also mean that the speed is constant, okay, or uniform. Okay, so just remind you all this. I think you should, all this here it's not much of a problem. Then of course when we came here, we had to practice using this formula, A equals V minus U over T, which practice quite a bit over here. Okay, I think now this should not be so much of a problem. Okay, and then after that, the next main thing will be the graphs of motion. Okay, when we talk about the graphs of motion, the first one will be the speed time graph. Remember, the speed time graph, the gradient gives you acceleration, okay, or the deceleration, right? So you want to look at the gradient tells you the acceleration. So as I taught you last time, whatever the acceleration is, the gradient is. And what do I mean? So if I tell you the gradient is positive 5, okay, it means the acceleration is 5 meters per second squared. Or if I say that the gradient happened to be minus 2, that means the deceleration is minus 2 meters per second squared. So whatever the acceleration or gradient or deceleration is, the gradient is, and also the other way around. Okay, and then of course you want to find the distance covered for a speed time graph. Do not use distance equals speed times time. Okay, find it by area under graph. So if it's a triangle, is a straight line, okay, you want to find the distance covered, it will be this triangle over here. Okay, yeah, so remember this, things like this. Okay, so and I ask you describe speed or describe acceleration, like all this which you did before. What are the adjectives you use? Keep telling you and remind you again, it's always the 4 adjectives: increasing, decreasing, constant, and 0. Okay, so look at this. Okay, always before you start to describe, look at the axis first. So it's a speed time axis. Speed time axis. Then you tell yourself, okay, speed time gradient is acceleration. So you even want to write this down, okay, so that it makes you aware what you're doing, because if it comes out distant time graph, you might get confused. So you know that the gradient is acceleration. So if they were to ask you to describe, okay, describe the motion of P, what must you say? Do not say the motion is increasing. That's totally wrong. When you ask to describe motion, you always talk in terms of speed and acceleration. So motion will be speed and acceleration. Okay, so ask yourself, what's the speed? Look at this. It's going up like that. So I will say the speed is increasing. Acceleration. Okay, acceleration, I remind myself, is the gradient. What's the gradient of this? Okay, the gradient is constant, right? Why? Because it's the same steepness everywhere. Okay, as I taught you last time, imagine this guy is standing here or here or here or here or here. The gradient is the same. The steepness is the same. So I say the acceleration is constant. Okay, whereas the speed is increasing. Okay, so do not make a mistake and say, oh, the gradient is increasing. Okay, then you're getting all confused, right? So, and when it is all this you've done before, right? So I mean, it's very worth going through and making sure that you can remember what you did. So even if, let's say, the graph is like that, speed time graph, okay, acceleration is the gradient, right? So what is the speed? Look at it. It's going down like this way. We say the speed is decreasing, right? Okay, I'll just use the arrow. Speed is decreasing. Then look at the acceleration. Now ask yourself, is this acceleration or deceleration? If the speed is decreasing, we say that it is decelerating. So then look at the gradient. The gradient is from here, not so steep, getting more steep, more steep, more steep, and here is very steep. So imagine, as I said, imagine the guy here, standing here, and then he's here. Here is so steep. So it has to be increasing steepness. Increasing steepness, increasing gradient means deceleration is increasing. All right, so go and practice this, go and look through, okay, how you describe the motion. Okay, be very able to describe the motion, okay, of all the various types of graph, whether it's in this direction, and so on. And after you've written it down, make sure you check and read again, see does it make sense. Okay, very often we forget to use the word deceleration. You might just say, oh, acceleration, whereas the speed is already going down, so it has to be deceleration. Okay, so always double check. It's not that you don't know, it's sometimes you're just careless. Okay, so and then when the time comes to practice, okay, you practice your questions over this. All right, go and practice, look through your notes again, how to find the distance and how to find the speed and so on. Okay, and then sometimes they will ask you to draw the graph. Okay, so what do you need to do? What's a good habit? Highlight important information. Okay, what does it say? Represent the motion of a body which accelerated at an increasing rate. Okay, increasing rate. So you should highlight this. Accelerated at increasing rate. From what? 0 to 5. From what? 0 to 10 seconds. And then travel at what? Constant speed. From when to when? And at what value? 5 meters per second. From 10 to 15. Then before decelerating at increasing rate from 15 to 20 seconds. So you highlight all the important information first. Then what do you do next? Do it part by part. Don't try to do everything at one go. Just break it into parts. Okay, 0 to 10 seconds first. Just concentrate on 0 to 10 seconds. Okay, you put 0 to 10 seconds here. Okay, you sketch, right? Use a ruler, okay, or and a pencil. And see what it says, accelerated at increasing rate. So accelerated at increasing rate. Acceleration, it means the speed is gaining. It's gaining at increasing rate. Increasing means what? The gradient is increasing. So from 0 to 10 seconds, the gradient is increasing. So ask yourself, how should I draw this? So you say, okay, I'll draw like that. After you've drawn, you double check. Gradient increasing, increasing rate. Gradient is increasing. Yes, it's an increasing rate. That's correct. And from to what speed? 5 meters per second. Okay, so it's important you break it apart, highlight important information, write things down like that. 0 to 10 seconds, gradient increasing. Why? Because it's going at an increasing rate. So come to this, settle this. Next, 0 to 10 seconds, traveling at a constant speed of 5 meters per second from 10 to 15 meters. Okay, this is quite easy. Constant speed. So this goes a straight line. Okay, until what? What is it? 15. Okay, I think I drew it too long. Okay, never mind. This is just a sketch. Okay, 0 to 10 is too short. Then 5 here is so long. Okay, never mind. Constant. After you're drawn, you always check. Is this constant? Yes, it's a flat line. Okay, then decelerated at an increasing rate. Okay, this one sounds confusing. 15 to 20 seconds to what? Rest. Rest means 0. Okay, so here 20. Okay, deceleration, that means coming down at a decreasing rate. So you can write down by the side 15 to 20 seconds decelerated at a decreasing rate. Decreasing rate means gradient is going down. So it's getting less and less steep. So what is less and less steep? So you draw this. Then after you're drawn, every time after you're drawn, you check. Okay, here very steep, then less and less steep, less and less steep. Okay, gradient is increasing. Correct. So it's very important to always double check whatever you're drawn. Okay, so again I say, what's your approach? Firstly, your approach is highlight important information. Okay, then break it into parts. Do the first 10 seconds first, then the next 10 to 15 seconds, then the next 15 to 20 seconds. Right? Within each part, always be careful of the gradient. Okay, is it increasing, decreasing, or is it constant gradient? Then after you're drawn with a pencil, you double check and make sure you're drawn correctly. Okay, always do that. And then don't forget to label the important values. Okay, there's no point you draw the shape, everything correct, but forgot to put the values. Okay, so you definitely can do this. Okay, you just have to be careful, break it apart, read the information out carefully. All right. Then after that, maybe they'll ask you, okay, calculate the distance traveled, everything. There will be area on the graph, or calculate the acceleration, then just use A equals V minus U over T. Okay, so that is just for the speed time graph. Okay, so let's pause here.